welcome back to our Scala to Spark data analysis and database course. And today we're gonna start talking about NoSQL databases. We have been learning about relational models, how SQL works, some of the more advanced commands, and now we will proceed on to NoSQL, different types. We'll look at different types of NoSQL databases. Again, I'll be using some of the books I'm using is Designing Data Intensive Applications. It's a great book by Martin Kleppmann. And there's some other nice books, but this is one of the good start. So let me show you also a nice picture, right? Where we are. This is from the book actually, but maybe you can find somewhere else. And we have been living in SQL Life. My SQLite is also here. So this is all SQL relational empire. Everything is relational, right? And we will look at the four major NoSQL databases types, right? We'll look at them. And document types, meaning MongoDB is a particular example we'll look at. We'll look at today, especially we'll look at key value databases, especially REDIS, which will be our example. And also we'll look later on. We'll look at the column family databases, Cassandra especially, and finally, last but not the least, will be graph databases, which are represented by Neo4j in our course. Okay, so that's our plan. Probably going to take next 2 weeks or so, and we'll start with a little bit of history. So, well, as you see, we'll go to second chapter already, right on, and we'll go to the idea, right? I already talked about in the previous course about Edgar Code and his invention, this relational database model, right, where we organize everything into tables, right? And of course there is a relation, right? Each relation is an officially unordered collection of tuples, rows in SQL, right? And this is all purely theoretical, but the practical implementation starting late 70s, late 80s has proven to be remarkably resilient, and it's basically been dominating forever actually, and it doesn't show any signs of changing. So again, if we go into our DB engines combine benchmarks, right? I believe no popularity, right? And the popularity, I believe, if you go here, ranking, right? You can see already that Oracle, MySQL, MySQL Data, Postgres, these are all four are SQL relational database. Only at 5th place you have a MongoDB, which is a NoSQL database type, and Redis, which is today's subject, is in place number 6. And then you still have some more SQLite, right? Again, top 10 still, right? Again, and there's MariaDB, SQLite. Again, Access for some reason is showing some resilience here, but again, many SQL databases again are, so basically top is dominated by SQL. So if all you knew was SQL databases, you would still be okay, right? But there was a need. You'll see it's actually there are places where something besides SQL is needed. So again, it's unfortunate it doesn't, again, NoSQL, it's a catchy name, right? Again, like I said, it basically means it's something which does not meet SQL database specifications, needs, right? It's something different, right? So it just became a catchword, like, you know, Web 1, Web 2, Web 3, and so on. So NoSQL is also a little bit of a buzzword, right? Again, so pretty much, you know, anything which does not fit into a relational database mold is going to be called NoSQL. But there are 4 major categories, right? So again, so that's again, since I would say it's even late 2000s already, you had this idea of something different. Yes, briefly touched on, there were such things as XML databases. They really were, if you see the picture, right, it's a ruins. You don't really use them anymore. You don't see them, right? If you need to store XML data, you usually use an SQL or some other, or just regular NoSQL database, but they're not pure XML database. I don't know of any in production, active production anymore. Again, so don't have to worry about those, right? But you'll see that JSON will be important, especially in MongoDB, right? So that's something we'll have to consider. And there's another article, right? This is from Database Zone, another another book. I may add this also, Introducing Data Science. Again, just an introduction. Again, that there are 4 big NoSQL types. So key value store, document store, column-oriented database, and graph database. Again, well, again, they are more specialized than relational database, right? Again, well, the thing is, of course, they really, they're still very, I mean, these databases are still popular, but many are learning, again, that just your plain SQL often is good enough, right? So, but of course, in a work setting, you don't know what kind of system you're working on, and you might encounter NoSQL database in person, of course, right? So again, so relational database is, again, what's one of the defining characteristics is making sure everything stored only once, using normalization, meaning use these tables, right? If you have a person, right, and you need to refer to this person multiple times in different tables, right? You don't write the full information about this person, name, last name, phone number, and everything. You have a separate table with that person, information for this person, and you refer by in the other table you refer by the foreign key, right? And you have all information. If you need to, you can join it and you can retrieve all the information, right? So that's one of the marks of SQL, is this normalization, right? Right, you have multiple relations, right? But again, so if you look at, I'll skip now column-oriented database. That's for in a few lectures, and I'll talk about key value stores, right? So they are actually, today's topic is the least complex. It's actually extremely simple, right? They basically are key value stores. So what does it mean? It means just like a map, like a hash map, right? Which we've been using in Scala, right? That's all it really is, right? Underneath NoSQL database, key value stores, basically everything, you have keys and you have values, right? So a value could be anything, right? And of course you can do nesting, right? You can do nesting. Again, some examples: Redis, Voldemort, Amazon's Dynamo. I believe Dynamo was based on something else. I believe Amazon has this tendency to use different bases. Let me see if I remember correctly. It was based on Dynamo. It is based on Amazon services, but I wonder if it has it. I am pretty sure it has some other dynamic, yes, or maybe it is actually one of the inspirations, actually, right? Never released paper, right? So one of those cases where actually Amazon was first, right? So other things came after it, right? But again, but the basic idea is key and value store, right? So quick access using some key, and you get extremely fast, constant time. Not even have a billion or even maybe trillion entries, and you get extremely fast access. So of course it's quite a bit more limited. So where do you use these type of database? One of those uses are as a caching, meaning you have some more complex data storage retrieval system, but you need to store something which you recently used, like key value store is perfect for this, right? You looked up something recently, you would use a key value database to store recently used entries, basically, sort of like a intermediate, like somebody, your assistant, you could say, somebody who hands you your recently used information, right? So that's one of the uses where you will use this database, right? And well, document stores we'll look at later, and graph database will be our last topic. My favorites are actually the graph databases. I'll give you because they're quite a bit different than the other ones, right? But we'll start with Redis. So with this introduction out of the way, let's get started on Redis. And where is our Redis? We'll get the Cloud Console afterwards, and we're gonna try Redis, but actually I'll show you the main page, right? And we go here, right? It's general. One of the main things about Redis, it's in-memory data store, meaning it stays in your or cloud computer, somebody else's computer memory, right? So again, you can use it as database, you can cache, right? Something which stores your usually most recently used information, but you know, pretty much you can store anything, of course. Again, so it's pretty loose. I mean, anything. Again, the main defining feature is this setting of keys and getting of the keys values from these keys. Right. So again, of course, commercial interests. It really started as a caching simple store. They've added inevitably every information system, well, it starts growing, adding some extra features which maybe are a little bit away from the original goal, but okay, but that's maybe slightly business related because it's too simple. And again, it's open source, right? So anybody can download, install Redis at your own computer, but of course Redis has to make money as well, right? So they have some, of course, commercial needs too. Okay, so but let's take a look at our tutorial. It's at Try Redis.io. It's official one. It looks kind of funny, right? But so it will demonstrate how does Redis works. So we can try tutorial, right? We can type it, right? So it is a family database called key value stores, like I was saying, right? And the basic idea is this. You use two simple commands, set and get. Really simple stuff. So again, I can set this, of course, I'm accessing the Redis server, right? Some small tiny machine somewhere, on set my name, right? And I do Valdis, right? Right, okay, so the server says okay, and I can get my name, right? I'll get my name. So that's my key, right? And this is a big thing again. So very simple, right? In these examples, of course, you can use different, you know, like a server name, that's fine, or my, you know, a dog, you know, cat1, cat2, you know, set cat house, cat maybe animal. I could do this cat, you know, cat, you know, I could do this, you know, fluffy, right? You know, and I can get animal cat, right? And of course it's just same as using my name, right? So this colon that I use as an example, they don't actually say this actually has no extra meaning. It's just a way of separating, you know, different you know, concerns. But otherwise you can use anything like this, right? So basically store permanently. Well, of course, permanently means as long as the server is running, right? As long as you have your memory running. So, okay, so that's the basic thing. We can also check, what kind of keys we have, right? We have exists, right? We can do exists my name. Let's check. Yes. Exists your name? Nope, no such thing, right? And also notice things, yeah, it gives you integer here. It tells you, so there's some types, right? So there's some types, right? So we get 0, right? My name, your name doesn't exist. My name exists. Okay, great. So you can check again without actually getting the key. Speed-wise, this might be slightly faster, but again, get is extremely fast itself. That's the whole idea behind this database type. Okay, but let's take a few more things. We have some time. So we can take a look, right? And let's take a look, right? We can do some, we can of course delete, right? If I don't like it, I can delete my name, right? Well, I'll delete, let's do set connections, right? Connections, right? And I'll do 10, right? And of course I can get connections, right? And I have 10. Notice it's actually string. It gives you a string representation. What will happen if I do increment, right? Increment connections, right? It gives you back integers. Very interesting, right? It increment, right? So I can do increment by, right? By 9000, of course, right? Of course I need a key, right? I need a key. Connections, and again, connections is just the key we decided on. There's no specific meaning behind it, right? So 9011. Okay, great. Okay, that works fine. We can also delete. Yeah, the question is now, if I delete connections, right? Right, nothing. Give me 1, but key exists connections. Is it exist or not? This is a very interesting point. It doesn't exist. So the question is now, if I do increment connections, remember connections does not exist yet. So what happens now? Well, I'll give maybe 55. Will it work? Right. Let me see. Increment by. Was it? let me see here, increment connections, increment delete connections, right? And I wonder actually, increment. So actually I had expect one, so I can do increment, right? Increment. Let's see what happens. Increment connections. Does it work? Yeah, actually it works. Oh, okay, yeah. Increment, right? So I get one, right? And increment connections again. Connections again. 2, of course, right? So get connections will be 2, of course. Yeah, the only thing get gives you strings or some technical. So obviously there's some slight technical difference between you get the integer. It's actually an integer, right? We are doing work here, but we're getting back here a string. So what happens if I increment my name? It should be an error, right? It should be an error. I mean, exists my name, right? Exists my name. Yeah, it exists. But if I increment, what will happen? It should be an error, right? Because it's not because my name, right? Remember, get my name, right? It's Valdis, so you can't increment a Valdis, right? It won't be, I don't know, Valdis 1 or Valdis 2. You can't do that, right? So what else? So yeah, I was going to say, let me delete connections. Let me delete connections, right? Again, or maybe I'll make them as my new key, my key, right? I'll do my key, but again, so increment by, let's see again, 5,000, what will happen? Connections 5,000, right? Yeah, it actually works. So notice, so we did not have a key. I mean, we had deleted it. There is no such key yet. And I incremented, right? I have 5,000. So again, increment by new key, some key, right? And I'll do minus 400. Let's say what happens. Yeah, it works fine. So get some key, and you have minus 400. Again, I increment some key, and you have minus 399. Okay, so everything works. Again, very simple system, right? You can get, set, right? And you can also, well, some convenience features, right? If you don't have a key, you can immediately set it up, right? By, so by increment by connections, it sets the key to 0 and immediately increments by 5,000. So in effect, you have 5,000. Of course, you could use this as set instead, right? So set, what happens if I do this? Set number key, right? Let's say 300, right? And can I do this? Increment number key should be 401, right? Right? Yeah, it works. Okay, so everything works. So we have, you have integers and you have strings. Okay, I think that's enough. And we can of course decrement also. Decrement by, of course, increment by is negative, same as decrement by, right? So basically these are counters. So this is a very, very popular application for Redis, because, well, the counter is guaranteed to work, right? So decrement, you can check that out as well. Decrement by, let's say 500, of course some key, number key, let's say 500, right? Or 300, and it's 101, and so of course decrement number key, and you have 100. Okay, so simple commands. You can set keys, get keys, you can increment keys if they're numeric. You can increment or decrement by. Again, originally I believe not all the commands were present in Redis. If I remember correctly, it was 10 years ago. Of course, some of these are purely convenience features added later on. Okay, so let's continue. We want to go next, right? Right. So so it's x get, right? So the thing is, again, so why do you need these actual keys? So there's a philosophical or database related reason for these increments. Well, because Redis can be used in a multiple client setting, right? It's extremely important. If you did it like this, right? I mean, in your program, right? It's get set, right? Well, the problem is if you have a single person using it, right? If you have a single person, no problem. However, if you have two people using it, two people read count as 10, right? There's 10 here. Let's assume there's 10. And if they both increment set count to 1 and 1, right? And if it happens, and this is, takes maybe a couple thousandths of a second, it will happen. You have a collision, basically you have a conflict, and they both set to 11, but we want to be 12, right? Because they both read at 10, right? so it was not atomic. So this is not this type of operation was not atomic. Didn't right? It's was not an atomic operation. Very important concept, right? So increment will prevent it. That's why you want to use increment or increment by, because it's atomic. It guarantees. I mean, it could theoretically fail, right, at some point if it give you something, right? But so all the REDIS operations are atomic, at least by single command, implement by single commands. So if you use a single command, you guaranteed an atomic operation, right? So including the ones operating on more complex data structures. So this is an important point, right? Okay, so use command modifies. You don't have to think about the concurrent access, right? Okay, time to leave, right? So right, you can add a time to leave lock. So expire, you can say when it should expire, right? So set my timer, right? You actually will see it, right? We'll see a time, right? Yes, and I'll say it something. Of course, right now it's not going to be a timer yet, so we'll call it. I'll say Scala to Spark, something like on, right? It's okay, I can get it, right? It's just like a regular key. So for now, right, get timer, right? But I can say put the time to live. I can give it expire, right? This is, I can give it a counter, expire my timer. I'll give it 60, right? Okay, and now I have to really hurry. Time to live, and my timer should be like 52. So 8 seconds have passed, right? At some point it will run out, right? And I think we'll let it run out. So time to live, I can of course set it up again, time to live, right? So we can also set it out to, we can do it directly. Set also, you see there's a one way of setting it directly using one-liner, x5, right? You set some key value and you say, okay, it has to live 5 seconds. So let's check while I'm talking, time to live my timer. Oh, we have 21 seconds left. Looks like we're doing good. Right, we have 23 minutes, right? And let's see, how are we going to do this? Should end soon, right? And we'll see. Time to live. My timer, we should be done. 0. Okay, my timer should be -1, I believe. Yeah, -2 actually. Right, just keep doing it. -2 actually. Yeah, okay, -2. Question is, what's -1? So -2 means key does not exist anymore. Okay, -1 time to live for key means it never expires. Okay, so let's see. That's very interesting. So again, this is one of those cases where the designers of this database, a single person designed this REDIS like about 15 years ago or so. And time to leave my name, right, should be -1 if I'm correct. Yes, you see. So why is -1? Because this has no expiration date. So they use -1 to represent information that this particular key does not have expiration. However, my timer, let's check, does it exist? Exists my name, right? Yeah, exists my timer. What will happen? 0, right? So it's dead. So -10. So can I do time to live something? No such key. Time to live, no such key. -2. So basically, if it doesn't exist anymore, right, it gives you -2 as well. This is just not such key. Okay, so that's timer. So you have an option to set timer. Also, you can do a persistence. You can decide, okay, I want it to live forever. I can do persistence also, right? And the value will be back. Question is, can you get it back? Persist my counter. Can I still do it? I don't think you can, but no, you can. So let's see, get my counter nil. Well, the thing is, it expires, so it's empty. It's theoretically yes. So set my counter again, something, right? You can notice what's interesting. The counter itself can have a value of string. It doesn't have to be a number, right? The timer is that's the time. Not my timer, I think, right? So get my timer. Nil still also, right? So set my timer, say again counter Well, let's say expires 30, right? So time to live my timer will be 20 something, and then persist my timer, and it's 1, and time to live my timer minus. Okay, so it's good, right? So get my timer and its counter. Okay, right. So that's the idea of timer. All right, let's do next. Right, so you have an option doing timers, and they're more complex structures. Right, you can use lists, which of course we know. Well, in Scala we know list structures, arrays basically, right? So it's somehow ordered values, right? So basically, let's do that also. So we are gonna push at the end of the list, right? We can do left push or right push, basically. Again, you don't create again. So one of the concepts, one of the key concepts is here, key, pun intended. You don't create a key and add the keys to it later. You can just start using it directly. So whenever you do use something, right, you will get a list. So we have no list friends, but we can start doing it. So R push or left push, of course, right? Friends, and I do Alice, of course. I like Alice. So, right, how about Bob? Friends, Bob, right? Okay, and Carol will be next, right? Oh yeah, I can't type. You see, push. I'm using, by the way, I can use this, right? You see, I'm using arrows. I'm using arrows even in this, even this simple environment has arrows too. Yeah, okay. So can I list? So left push, friends. I don't know, all this, there is name for all this, right? All this, right? Also works. Okay. Question is now, can you see L pop, L range? Yeah, the thing is, how do you see it here? So let's see what L range was. I believe Redis L range, right? Was, yeah. This is from version 1, so very easy. Notice also thing is. This is documentation commands right here, right? Look at all these commands, not too many, I mean, but still. So you push, you can get 0, you can get everything. So something like this, even -3, right? So this is like getting everything. So L range, or can I get, well, let's see if we can get it completely. Oh, come on, I'm here, right? Get, what happens with get friends? I like get friends, right? Who doesn't, right? Right, you can't, you see, that's maybe slightly well, for those who are new to Redis, slightly unexpected. You don't get, because this is a list, so you have to do this L range, and let's do something, I don't know, 0, 2, friends, 0, 2, yeah, so it works, of course. L range, friends, I don't know, -300, 5 something, also works, right? Notice, right? So even silly values. However, if I do 1, right? So Alice and Bob, what happened to all this? Well, he's 0, right? He's number 0, right? So the range is 0 indexed, but interesting enough, we get 1, 2, 3 here, right? But of course, 0 indexed anyways. Okay, so that's another thing. So you have a list type. Okay, we'll maybe get to it later. We'll play around with it later. We have time, but so you can push things and pop. Of course, you can put pop. And so question is, what's pop? So right pop friends will be what? All this for Bob. Let's check. Bob, because he was last, right? So right pop, and of course left pop. Friends will be all this. Now we know. Okay, no, there's nothing to pop here, right? All this. And so what do we have left? So get L range, 0, friends. And it's Alice alone, but yes, I can show you, minus something, Alice alone. Of course, generally you don't want this. I mean, if you know the range of items, you don't have to do these silly numbers. You can just do regular right numbers. So one of those things is in Redis, the end is included, right? It's like in between in SQL, right? In between, so it's start and beginning and end is included. So Alice is only one left. Only have one friend left. Okay, so that's another helper. And let's do one more. Right. And yeah, so key value. Or okay, we did that already. Decrement. We did the reading. That's it, I think. Time to live. Next. on, is that it? Range, right, like I said. Oh, by the way, on the, yes, Sam Alice Bob, Sam Alice, penultimate, that's the last one, right? -2, right? So you can do negative index as well, right? So this -1 actually includes Bob as well, right? -2 would not include Bob, right? Okay. On range, we can, yeah, we can do range of friends. How many friends do I have? Let's check. Maybe something I shouldn't check, but yes, I'll do. So left range, friends will be 1, right? And let's add one more, right? Push, right? Yeah, right. Push friends Edgar's, for example, right? And right, and of course now length friends will be 2, right? Okay, great. All right. So let's see, do we have any more? All right, push, right. So I can push multiple friends, right? So yeah, that's again, I can push multiple friends. That's also possible, right? If I do, right, push again, Bob and Carol, friends, Bob, Carol. Yeah, and length, it tells me it's 4, but of course it isn't 4, so let range 0. So let's see, minus, so 3, right? Friends. Yeah, it's, yeah, Alice, Edgar's, Bob, and Carol. Okay, works. Okay, great. Pretty easy, right? So let's take a view, let's see how much time we have. I also want to do a technical, yeah, so 32 minutes. And yes, we can add set. Well, we know sets as well, right? We know sets. Well, again, one of those. Remember, no order. Each element has to appear only once. So again, very similar things we looked in Scala in our data structures in our collections. So a set. Again, you have set add, right? Sad superpowers, right? Flight. And again, there is no such thing as flight. Yeah, so only problem is, of course, would be nice to get, but some members, right? So let's get that. Sad superpowers, you know, I don't know, fire, I don't know, water, right? So now we can do union, of course. It's much more limited, of course, so I can remove something, but let's say I can check is member, superpowers, and let's try fire. I think you can do check. I think I'll do this, I forget now. Yeah, it isn't. And so if this is fire but air is not superpowers, 0. Okay, yeah, that works. Okay, so 0 or 1, right? I'm going to get all of them immediately, right? Union, no, I guess I don't think so. Okay, so it's very similar idea, right? You have sets. Again, I'm just giving you, or you maybe we'll get back to it later. I think there's one more, right? Structure, sad, union, right. So if you add something which shall exist, you'll get 0. If you add something which doesn't exist, you get 1. Okay, but let's see one more structure, right? Pop, we can add pop, of course, right? Again, remember the main thing difference between sets and lists, of course, is this ability to have only not ability but requirement to you only have unique numbers, right? So then sorted. Oh, there's again, this is newer. Redis introduced sorted sets, so they are sorted like regular set, but also there's a score. Right, so you can do something score, but we'll talk about this later on. Maybe this is so more advanced stuff. We'll want to get to the technical issues of setting up your own connection to Redis, right? So there's also hashes, right? You can set, right? So string sets, storage sets we already have. There's one more type is hashes, right? So maps in string fields and string values, right? To represent object, right? So you set a user, right? And name, and so and get all users with this set, right? So let's check how this works. So the maps within string fields and string values, right? So basically you can get everything, right? So it's basically sort of a bigger entity, right? You're not just a, so you set you have a, you can get everything from this hash set, or you can get a separate specific thing, right? You can get a specific field. You see the idea? So if I do hset user, let's say 100, that's me, let's say, I don't know, name Valdis, you know, for salesperson, right? On, right? Again, I can again remember the thing. There was no such thing as user 100. I just came up with it once I start using, right? Well, this coding at gmail.com, right? And I set it up, right? Okay. On hset password or super secret, right? Again, user 100 password. Again, those are all. These are not. None of these were written anywhere in Redis. I mean, these are just came up. Okay, I need this. I need the user key user colon 100. Okay. And I need some fields: name, email, and password. You know, super secret, super secret, and yes. Okay, and I can get all, right? User 100. Oh, what did I do wrong? Oh, sorry. hget all. Yeah. So Horacium. Yeah. Okay. An interesting name. Right. Name. Well, this email. Well, this is right. So. Let's see, did I do it correctly or did I make a mistake? Right, but can I get one? Oh yeah, let's try this. So hget user 100, and I want to get email. Yeah, it works. So when I get all, you have all of the, so basically these are pairs. Again, think of this key, so underneath, right, underneath this object, so key user 100, you get these multiple values back, but these are related. So email, right? But I can do so password, of course, as well, right? I can do password, of course, right? No such field, right? It'll be error, nil. Well, actually, no error, but just nil. So, but if I do password, I'll have super secret, right? Yeah, super secret. But however, I'm pretty sure I can do reverse. Let's try this. Super secret won't work. No, it's nil because. So these are the internal field names, basically, right? So again, slightly more complex, not about as complex as it gets, really, right? Right, and you can do hash fields, right? You can do it more, again, make it more complex, so you can keep it. So again, you can have some structure, right, for your objects, right? So something which you want to combine multiple, you know, values somehow, structures them a little bit. So that's a very minimal way of structuring, but you can, right? So you can increment individual fields as well if you want, right? So that's it. That's it for the short introduction. I was very brief on the last entries because the next task, and this will be mostly also your assignment, will be to set up an instance of Redis on the cloud. So that's what we will be doing next. Thank you.